So we have video solutions for Unit 7, Packet 144 through 182, even solving systems of linear equations using elimination. So we've already learned how to solve systems of equations using graphing, which is very accurate, but it's a good way to estimate or to check our work. We've solved systems of equations using substitution, and that's where I look for a variable that's by itself. But now we're going to solve systems of equations with elimination. And what we're looking for in elimination is we're looking for either the same coefficient in front of the x or y or the opposite coefficient. So we know opposite is +1, -1, +3, -3, and so forth. So we still have to get rid of either the x or y variables so that we only have one letter left to solve for. So we still have to do that. Then when we're done, we still have to substitute that x or y back into one of the equations to get the other coordinates. We still have to do that part. So let's start right here with 144. You'll see this is actually, it's a little easier than the substitution. Okay, so I'm going to use my highlighter. So what I'm looking for is either the same coefficient, which we know is the number in front, or the opposite coefficient. Okay? So, look here. So here I have a 2 and a 3. They're not the same and they're not opposites, are they? Look here. What would be in front here? What would be in front here? They're the same. So that tells you I'm going to use the elimination method. Here's all I do. I'm actually going to do my work like I'm in elementary school. Okay, they're lined up. When they're exactly the same coefficient, I'm going to add, but then I'm going to change everything in the second equation to its opposite. So that was positive, now it's negative. That's positive, now it's negative. That's positive, now it's negative. And then I'm just going to add going down. So watch it happen. 25 and -33 is a -8. I have my equals. 2y and -3y is a -y. And here's why we use the elimination method. What's a positive x and a negative x? Nothing. They cancel, and there's why I'm left with only one letter. Okay, when we have a negative in front of the variable, we can just, as a shortcut, change the sign of everything. So my answer is actually y = 8. Now take, substitute that back into one of the equations. So x plus 2 times 8 equals 25. X plus 16 equals 25. And now you're just solving equations. So x equals, what is it, 9? So you have the ordered pair of 9, 8. Make sure you put your x first. So that's where these two would cross. Okay? All right, so let's go on. Let's do 146. So this takes practice because it's different than what you've ever done. All right. So again, we would look for a variable by itself if we were doing substitution. So I don't see one. So now we look for elimination method, which means I'm looking for a coefficient either in front of the x's or in front of the y's that are exactly the same or are opposites. So do you see any up there? Yes, right here, the 2 and the -2. So now, unlike the last problem when they were the same, and we added and changed all the signs, this one's already set up. We just add. We just add them up. So 4 and 60 is 64. 3y and 5y is 8y. And then, of course, look what happens. 2x and -2x cancel, which is the whole point. Now do your math, and y = 8. Simple, huh? It's a little easier than substitution when you get the hang of it. So y = 8, so now we substitute that 8 back in for y, so we have 2x plus 3 times 8 is 4. So 2x plus 24 equals 4. So we subtract 24 on each side. So 2x equals 20. And then divide by 2, x equals 10. So our ordered pair is 10, 8.
This is actually a lot easier.
Yeah, it will be.
I was like, because when I first saw it, I was like,
Well, it's because it's brand new. Okay, so 148. So what are we looking for? We're either looking for a variable by itself for the substitution method, or we're looking for the same coefficient or opposite coefficients for the elimination. So in this one, it's kind of nice because I can do either one. This is a -1. That's a +1. Or this is a +2 and that's -2. It doesn't matter which one you use. So let's go ahead and say, let's just use this right there. Okay, so then, now, when they're opposites, remember, all you got to do is add. So I'm going to always do my same change switch here, just because I don't like that subtraction. Okay, so here's where we just add them. We don't have to change the sign of anything. So 14 and -11 is 3. Our 2y and -2y cancel. Now look what happens here. Our -x and +x do what? Uh-oh, so what's on this side? Nothing. What happens when you get rid of the variables and your end result isn't equal? No solution, which means that these two lines on a graph would look like what? They'd be parallel, which means that these two equations would have what in common? Same slope. Very good. Very good. Okay, 150. That's right. Whoopsie.
Talking. It helps out a lot.
All right. Yeah, and then just discussing stuff. Okay, so no variable by itself, so which one am I going to eliminate? The x's or the y's?
The x's.
Because I have opposite coefficients, huh? So that means I do what? Add or add and change the sign? I just add. They're already set up to cancel. So this is going to be -18. This is going to be 6y, and these cancel. So now I divide by 6, divide by 6. So left with y equals -3. All right, let's substitute correctly this time. So 2x plus 5 times -3 equals 5. So 2x plus -15 equals 5. And then we just solve the equation. So the faster you are at this, the faster you actually can do the whole problem. Okay. Divide by 2. Oh. And x equals -5. So my order pair is -5, -3. Let's substitute just in case I think I messed up.
What did it be?
Okay, somewhere. Oh, that's positive. I knew I messed up somewhere. There we go. It just didn't seem right. So this was a +20. So now divide by 2, x would really be what? 10. Yeah, it just didn't seem right. It seemed like I was messed up. So then that would be +10. So let's substitute. So 2 times 10 would be 20. 5 times -3 would be
15.
-15. 20 plus -15 is 5. So, yeah, now we're right. Okay, good. Okay, 152. All right, same process again. We're looking for either variables by themselves for substitution, or we're looking for coefficients that are the same or opposite. So which ones are we going to eliminate here, x's or y's? X's, okay, because I have opposite coefficients. So what's my method then? What do? I just add. I don't have to change anything else. So notice what happens here. These are going to give me 0, which is fine. That's going to be an 8y. That's going to cancel. So I divide by 8. 0 divided by anything is what? 0. Okay, which is fine. That just means my intersection is be on the x-axis. Okay. Substitute 0 back in for y. Okay, so I'm going to have 5x. That's going to be nothing. Equals 40. So and I divide by 5. So this is all the same. So x equals 8. So my coordinates are 8, 0.
This is a lot easier than x.
Okay. 154. All right. Again, we would look for substitution or you look for elimination first, depending on which method you think is easier. Okay, which variable am I going to get rid of on this one?
The y's, but you'll change the
Okay,
sign.
the y's, because they're exactly the same. So this time, I have to add, and then do what?
Change the sign.
Change the sign of everything. So that was negative, now it's positive. This was positive, now it's negative. And then this is negative. Very good. And that's the only little twist there. So then I have negative 42.
Which is where it's going to mess up.
Exactly, that's why practice. Practice. Those cancel, I get 6x and divide by 6. When you use the elimination method, you just don't have as confusing of an equation.
Yeah.
It makes it a little bit easier. So x is going to be negative 7. Okay, put negative 7 in for the x this time. Plus 4y equals 10. Negative 14 plus 4y equals 10. Opposite of the number. Opposite of the operation. Y equals 6. And then so your point of intersection is negative 7, positive 6. Okay? All right, 156. Got to get there. Okay. Okay, well, we're going to end this part, and then we'll go to the next one real quick, and I'll show you how you do the next part with multiplication and division. All right, so it looks like we have opposite, all right. Looks like we have opposite y's right there. So we know our method then is to simply add, right? So I'm going to do my same change switch. All right, so I have 39 and negative 45 is negative 6. They cancel. Negative 4x and positive 5x is just x. So you're done. That was easy. Okay, substitute negative 6 in for your x and solve for y. So that's what, 24? Okay, subtract 24 on each side. So 3y equals 15, so y equals 5. Make sense?
Yeah.
I know I'm going a little fast, but that's why when you watch the video, you can slow it down, right? You can go back and forth and stuff. Okay, so now, we're going to end there. You can do the rest on your own a little bit. Okay, so we know from the last part that when we used the elimination method, we were looking for the same coefficient or opposite coefficients. So for example, in number 162, we have opposite coefficients right here. Okay, so we know that we would just add those two equations up, the x's would cancel, and then you'd have y's, and you could solve for y and move on. But now what happens when you have equations that have neither the same or opposite? So we're going to find it's just one extra little step. So let's go to 164. Okay, and I'm going to do my same change switch right now. Okay, so here I have a 3 and a negative 4. Not the same, not opposites. Here I have a negative 2 and a negative 4. Not the same, not opposites. So we have to make them the same. So the easiest thing to do is look for factors and multiples that go together, right? So obviously this 2 can be changed into the 4, can it?
Yes.
How do I do that? Multiply everything by 2. So that means I have to multiply everything in that equation by 2. So now it's basically distributive property, and then I rewrite it. So I have 6x plus negative 4y equals 66. And in the other one, I still have my negative 4x plus negative 4y equals 16. And now this problem looks like the ones we just got done doing. So I have the exact same coefficient in front of my y's. So what's my method? I have to add and change all the signs. There you go. And now I can do the adding. So that's going to be 50, negative 4y, positive 4y cancel, and I have 10x. So obviously I get 5. I'll go ahead and substitute the 5 back in. Doesn't matter which one you do. What?
Do you substitute it for the 3x?
Doesn't matter.
The original number,
Well, it doesn't matter because this right here is the same as this. It's just twice as big. So it's like saying this. There's 2/3. There's 4/6. They're exactly the same. All I did is multiplied by 2 over 2. So I'm still going to have the same equation. So I would substitute it in the original one because the numbers would be smaller, won't they? So I'm going to put the 5 right here for this. X. I have negative 4y equals 16. So that's negative 20. Plus negative 4y equals 16. So that's just a two-step equation. So add your 20 on both sides. And you get negative 4y equals 36. So divide by negative 4. And y equals what? Negative 9. So my point of intersection is 5, negative 9. All right?
All right. So I have to go now.
Okay, say goodbye.
Okay. Goodbye.
There you go. But this will be up. I'll put this up in just a little bit. It's 164. Gotta go to the next page. All right, 166. Thanks for the help.
Thank you.
Oopsie. All right. So again, I'm looking for coefficients that are the same or opposites. I don't see any. So which one of these sets of coefficients, with the x's or with the y's, are factors and multiples of each other? Yeah, the negative 3 and the 12. Okay, because I can multiply by 4. So, yeah, so I'm going to multiply everything here by 4. So my new equation will be negative 12x plus positive 12x equals what? Negative 80, negative 108. And then my original one here was 12x plus 5y. Whoop, that was a y, by the way. Plus 5y equals 108. All right. Notice that I have opposite coefficients. So what does that mean I do? Just add. I don't have to change anything else. Good. So this is going to be 0. That's going to be 17y, and these cancel. So again, we know that when we have 0 divided by anything, you get 0, right? Okay, substitute 0 back into the equation. So I have 12x. I'm going to put the 0 for that y. Okay, so that's going to be 12x. That's nothing. So then I divide by 12, and what is that? 9 times, right? Okay, so your ordered pair, or your point of intersection, is 9, 0. Making sense?
Yeah.
Okay. 160, what? 8? Okay, so which variable am I going to try to cancel?
The x's.
The x's, because the 2 and the 8 are factors and multiples. So I have to take this equation and multiply by what?
40.
Yeah, there we go. So that's going to be 8x, and I have to do everything in that equation. So that'll be a common error for kids, is they won't multiply everything. So again, it's this distributed property, everything. So that's negative 28. And then my other equation is 8x plus 3y equals 57. All right, so obviously my 8's are the same. So what do I do here?
You have to add and then change the sign.
Add and change the sign. So negative, that would be negative, and that would be negative. All right, what's that? Negative 70, negative 85. That's 17y. That's nothing. Divide by 17. Divide by 17. y is negative 5. It's nice when they turn out. Okay, now we're going to substitute. So 8x plus 3 times negative 5 equals 57. So 8x plus negative 15 equals 57. Okay, add 57, add 15. So 8x equals 72 divided by 8. And it's always, like I said, nice when it turns out because you pretty much know you did it right. So our ordered pair would be 9, negative 5. All right? All right, 170. Okay, so which one am I going to try to cancel?
The x's.
Yeah, because I had 3 and negative 9, so I can change 3 into 9. So I multiply everything by 3. Everything. So that's what? 9x plus 9y equals 93. And my original equation here is negative 9x, okay, minus 5y equals negative 67. So I'll do my same change switch. Okay, what do I have to do then? I want to get rid of these. 9 and negative 9. What's the method again?
Add.
You just add. Yep, you got it. The star, you and Christopher. Okay, so that's 26. It's, what'd I do? That's not going to come out. All right, so I got 9x plus 9y equals 93. Negative 9x plus negative 5y equals negative 67. That's 80, 93, isn't it? What's my problem here? Oh, no.
I don't know how to say S. Add it wrong. So
Where?
On 93 says so. It should.
We did. It's 26. Because minus 5y. It's negative 5y. Huh?
I don't see a problem. Oh.
Okay. Well, let's just assume that this one didn't come out right. No, it just is going to have, so let's say y equals, that's going to be 13 halves.
Oh, I see. Okay.
Okay, that's what I got. I mean, I don't see an error, do you?
No, I don't see it at all.
Okay, well, let's go with y equals 13 halves, and then we'll substitute. So now I got to put that back in to one of the equations. So I'm going to do the top one. So I have 3x plus 3 times 13 halves. Not everything turns out right or nice. So that's going to be 3x plus 39 halves equals 31. Okay, I want to get rid of that 2. So I'm going to multiply everything by 2. So that's 6x plus 2 over 2 is 1. So 39 times 1 is 39. And then 2 times that is 62. So now I can do my two-step equation. So 6x equals 23. So x equals 23 over 6. All right. So we'll check this tomorrow. Or maybe somebody else can find the error, but I couldn't find it. So we sometimes have yucky answers. Well, we'll double check. Please, I just don't see it. All right. 172. Okay, which variable are we going to get rid of? And this, it doesn't matter, does it? Because this is a 1, so I can either multiply by 4, or I can multiply by, did you listen to me say that? I can either multiply by 4 here, or I can multiply by 4 here. Oh, that sounds like there's going to be something goofy going on. So
It's about to be parallel lines.
we'll see, huh? So that's 8x plus 4y equals nothing. And then the other equation is negative 8x plus 4y equals 80. No, it looks like it won't. Okay, so which one do I want to get rid of?
The x.
Yeah, because they're already opposites. So that means all I have to do is add. I don't have to change anything else. So that's going to be 80, and that's going to be 8y. So, no, it comes out. Just sounded funny. So y equals 10. And substitute that in over here. All right, negative 8x plus 40 equals 80. So negative 40, negative 40. What you want to do is, you want to be able to do this as fast as me so that this part, which isn't the real lesson, it's just the work part, you can just do fast. You got to be good at solving equations.
I can do that part. Just, I can't write yours fast.
No, that's fine. All right, good. So our point is negative 5, 10. Well, you guys can just watch the video too.
Yeah.
Well, actually, you're going to be good. You're not going to have to do.
understand it, yeah.
You're not going to have to do any more homework. You're going to be good when you leave here. Okay, let's go back. 176. Okay, all right. Which one am I going to get rid of?
Turn it into the y's.
The y's, because I have 5 and 10. Those are factors and multiples of each other. So I'm going to multiply by 2, right? So I'm going to do my same change switch. All right, just got to do everything. So that's going to be negative 8x plus negative 10y equals negative 18. The other one is still the same. So 3x plus 10y equals 13. Okay, what do I do here? Add or add and switch the signs?
You stop.
Just add because those are already opposites. It's easy. Good. So that's negative 5. They would cancel. Use your highlighter too. You always know it cancels and stuff. And that would be negative 5x. So divide by negative 5, and x equals 1. Okay, substitute that in. So 3 times 1 plus 10y equals 13. 3 plus 10y equals 13. Okay, opposite of the number. And opposite of the operation. So y equals 1 again. So 1, 1. Okay, and we're going to end there.